So now that we've taken a look at an already created drafted part, let's start creating our own. Let's start by creating a new file using our part inch drafted template. And the first thing I want to do is I want to talk a little bit about drafting features by using sketches. Now this is not the common method to creating drafted parts, but I want to talk about it first so we don't overlook anything. Let's start by sketching on the front plane and using our line tool. We'll sketch from the origin, up, over to the right, down to the right at an angle, and then back to the origin. Now before we exit the line tool, I'm going to draw a vertical line from the bottom right hand point, hit the escape key, and while that's still selected, I'm going to change it to a construction line. Using my S key, I'll use Smart Dimensions to apply a dimension between these two edges, use my equal key on the keyboard, and set it equal to the global variable draft, green arrow to OK it, and now we have a dimension that's linked to our global variable for draft. Once we say OK, we'll go to the revolved boss base and select the vertical line that came from the origin as our axis of revolution. So as we're looking at this part, we'll do a section view using our front plane and take a look at it. So we made a revolved part and it has a tapered edge on the outside, so it has the available draft to be pulled out of a mold. Now it's not the common way to do it, but there are features like revolves that you can't draft on the fly. You have to do it at the sketch level. And the great thing is, doing it at the sketch level by linking it to our equations, we can come in and we can modify this to 5 degrees, rebuild our file, and now we have a 5-degree taper on this edge. If we go back to our sketch, you can see that it's updated to 5 degrees. So as I said, this is not the common method of creating drafted parts, but it's a good idea to understand that you can do it, especially with some features, by doing it at the sketch level. Now it's not limited to revolve. You could still do things like loft from one boundary to another and make sure that you have the available draft. And if you take a look at the other course on creating molded parts, I go into some more specific examples of using things like surfaces and helper surfaces to start creating very organic complex shapes by using initially a sketch that is a draft, essentially at a draft angle, to create those files. So let's go ahead and delete Revolve 1 and delete Sketch 1 as well. Now you'll notice when I do that, I get an error in my equation tree. This happens in SolidWorks, and if we go into the managed equations, you'll notice it's saying that there's a problem because dimension 1 at sketch 1 is no longer there. We don't have a sketch 1 anymore. So we simply need to select it, hit delete on our keyboard, and get rid of it. The next thing we want to talk about is creating draft inside of a feature. So from the top plane, go ahead and start a new sketch, use a center point rectangle from the origin. We'll have it go up 5 inches, and it'll be 10 inches wide. We now have a fully defined sketch. We can exit and use the extruded boss base. Now inside here, we're going to make this 5 inches tall, and you'll notice just below the dimension D1, we have a draft on-off button. Now if we select this, it'll turn the draft on. If we hit the equals key on our keyboard, we can then go ahead and link it to our global variable for draft. Now remember, we changed it to 5 degrees, so now it's linked to the global variable for 5 degrees of draft. That means if we go back into the equation manager at any point in time and change it, it will update this file. We also have the available option to draft it outward or inward. Now there's another option that I want to talk about in here, and that's thin feature. Now if you select thin feature and you give it a wall thickness that's thick enough, you'll notice that what we have is the outside drafting inward and the inside drafting outward. This results in a very thick wall at the bottom and a thin wall at the top. This might be okay for things like internal ribs or structural ribs. It's really not ideal for the outside of a drafted part. Remember, I talked about having a consistent wall thickness. It'll give you a much better result if the outside of your part, the cosmetic side, has a consistent wall thickness throughout. There is another option inside here called cap ends. It allows you to cap the original end of your sketch to make it a sealed container. But you'll notice that it ends up being pretty thin because it comes in at a default of 0.1. Now if we set this equal to 1 inch, you notice at the top and bottom now have a 1-inch cap on it, and it's a completely sealed part. It means we'd have to go back and do some extrude cuts or delete some faces in order to get it to be an open container. There are other options in here to do inward, outward, or 2 directions. But in general, the thin feature is not very useful for things like drafted parts because you don't have control over which direction the draft on the inside is going. And once you OK this operation, thin feature is now locked, and in order to get rid of it, you would have to delete the feature. So let's go ahead and turn off thin feature, and we're going to move forward with our extruded part drafting at 5 degrees inward. Once we say OK, we now have a solid body that has 5 degrees of draft on the outside. If we go into our equation manager, and let's say we change the draft to 8 degrees. As soon as we rebuild this, we now have an 8-degree draft on the outside of our part. Now, there are several different ways that we can get that consistent wall thickness. We can offset these faces using surface tools and then go ahead and delete or use them to delete the inside of the body. We can use another extrude from the inside, or we can do a few other things. But by far, the most handy tool, especially when you're dealing with complex parts, is using shell. Now, shell will allow us to do things like select a face, give it a wall thickness, and if you remember, we set up a wall thickness in this file already. So if we say equals global variable wall thickness, we now set that equal to our 0.125 value. We can show a preview and take a look at the result. So now let's go ahead and say OK. And notice that we now have the inside and the outside drafted in the same direction. If we do a section view using our front plane, you can see that the outside is going to be pulled from the top. So the mold will be pulled up as we're looking at it in the Y direction. And the inside will be pulled in the minus Y direction. And this is a typical orientation of a very simple drafted part. Now, the beauty of doing it this way is shell is now linked to the wall thickness value in our equation manager. If we come back in here and we say that we want a much thicker wall, let's say 0.25. When the file updates, we now have that thicker wall. And we can also roll back the feature tree above shell and do things like apply a nice fillet to all the corners. Now, when you're applying fillets, the quick context menu that pops up allows you some options. In this case, connected to start face or all the edges on the file. So I want to do all these outside edges, and we're going to go ahead and give it a 1-inch radius and say OK. Then we'll drag the end of the feature tree down. And now we have a shell that also has the offset of those fillets. So if we measure this by going to Tools, Evaluate, and Measure, you can measure the radius value at the bottom. So now we can measure the difference between this arc and notice that it's a consistent 1/4-inch thickness. So this means that if you have a radius value on the outside of 1 inch, and you have the 1/4-inch offset, you're going to have a radius value of 3/4 on the inside. This saves you the hassle of having to figure out these wall thickness values by yourself. If we drag our section view up, you'll notice that we have a nice consistent wall thickness all the way around our part now. And the wall thickness is going to be the most important or most crucial aspect of your cosmetic molded parts, because again, you don't want to have those imperfections on the outside of a part you're trying to sell to a customer.